Hello, in this video we're going to look at factoring trinomials in which the lead coefficient, the a term, is greater than 1. As you remember, a quadratic ax squared plus bx plus c equals f of x equals y takes this form for standing. This is what we call standard form of a quadratic. This is the form it takes on. And ultimately, when we factor these guys, we're trying to find the roots of the equation or the zeros of the equation. And that's when we set the f of x equal to 0. But we'll talk about that at a later time. But right now, I'm just focused on trying to find the two binomial terms of each of these. Now, sometimes these are not factorable, but we won't examine that in this video. We'll look at another video. We'll do that at a later time. So let's look at the first one, and we're going to use something that we call the AC method. Now, the AC method is named as such because I'm going to be multiplying the A times the C to find something to help me split the B. When we have a lead coefficient that is not 1, we can't simply do the splitting that we did in the other video. Some of you guys have gotten really good at factoring, and you can just split the lead term if it's just x squared, p squared, r squared, b squared, whatever it is. But when we have something other than 1 in front of that term, we can't just simply do a split, especially if we have a composite number here. Since we have a prime number, we know that one of the terms is going to be 3p and the other one's going to be p. When it's a composite number like 6, 9, 14, 20, then we run into more difficulty. So if you're trying to do it with mental math and trying to visually figure it out, you're going to struggle. So let's look at using the AC method here for each of these, and we can use that to kind of build when we get to composite lead coefficients. So when I'm looking at this here, first of all, my A and my C are positive 3 and negative 5. Now, the AC method calls for me to multiply these guys together first. You do have to pay attention to signs. This is a positive 3 and that is a negative 5. So when I multiply them out, I am going to get negative 15. So the next step is to find factors of negative 15. Now, how do you get a negative number when you're getting a factor? Well, the way you get a negative number is you have to multiply a positive times a negative. So here are my options. I can either do a negative 1 times a positive 15. I don't know why it does that. Or I can do a positive 1 times a negative 15. Or I can do a negative 3 times a positive 5. Or I can do a positive 3 times a negative 5. So there's a host of possibilities here. But what I have to do now that I've factored this out is I have to look at my B term. That's my negative 2. And I'm looking for two factors of 15, negative 15, a pair of factors that actually multiply, because they're factors, to give me negative 15, yet they sum or add to give me negative 2. So when I look at my factors, this is my choice. Positive 3 plus negative 5 gives me negative 2, which is what I want in the middle. Why am I doing this? Well, this is going to create an opportunity for me to split the middle term and factor by grouping. So let's actually put this in action. My lead stays the same. I've got 3p squared. But I'm going to take this negative 2 and I'm going to split it. I'm going to split it into positive 3p minus 5p, and then I'm going to put the minus 5 back in there, the subtraction. Why did I do that? Well, if you look at this, negative 2 is the same thing as 3p minus 5p. And sometimes you'll have to manipulate the order of your terms. What if I were writing my factors out the other way and I would have written negative 5 first and positive 3? Well, as you're going to notice, you need to make sure that you have things that you can group together so that you can get a common factor. So let's now employ grouping. We've done the multiplication, the factoring, and now the splitting of the B term. Why is this going to help us? Well, I'm going to group these two guys together. What do these two terms have in common? 3p squared and 3p. Well, actually, as it turns out, I can factor out a 3p, and I end up with p plus 1 as my cat starts scratching on the door over there. And then I'm going to look at my next two terms, which are negative 5p and negative 5. So what can I factor out of negative 5p and negative 5? Well, I can actually factor out a negative 5. I'm about to throw something at my cat. So I'm left with p plus 1. Now, with p plus 1, I can see that I have a common factor. I took a brief moment there to make sure my cat wasn't scratching in the background. Anyway, so I'm going to employ the same thing here. I'm going to look for the greatest common factor. So my greatest common factor now between these two is p plus 1. I can do the same thing here with p plus 1 that I did with 3p and what I did with negative 5. I can factor it out. So I have p plus 1. And when I factor out p plus 1, that leaves me with 3p minus 5. So those are my two factors, and that's my answer. P plus 1 times 3p minus 5. So again, that's the AC method. What I did was I multiplied a times c, and then I found two factors that gave me the b term, and split the b term and factored by grouping. So let's do this again. Now let's do it with number 2. So if I look at number 2, I'm going to do the same thing. I'm going to take a times c. Well, you know what? And as I'm going, I'm thinking I might be better served to do something like number 4 for you. And I'll show you why. Let's do number 4 instead. So number 4, I have 5 times positive 12. Now if I multiply a times c, and I see my cat approaching the door again, I'm going to get 5 times 12, which is 60. Now this is a positive 60. So whereas when we looked at the first example, we got a negative 15, we are now looking at a positive number. So with a positive number, we have two different types of factors. With negative number, you have to have a negative times a positive, and with a positive number, you have to do a negative times a negative, or you can do a positive times a positive. Sorry, another cat break. So where was I? We have a positive 60, so I'm going to have a negative times a negative or a positive times a positive. And as always, we're trying to find two factors that are going to give us a sum, when we add them, of the b term, which is positive 19. So obviously 1 and 60 would not be a good choice because 1 and 60 are 59 digits apart. That's not going to help us. So let's get to some more of the middle numbers for 60. Let's think of some common ones. So I can either have a negative 6 times a negative 10, or I can have a positive 6 times a positive 10. Do either of those add up to positive 19, my b term? No, they don't. So let's look at something else. Let's try positive 5 times positive 12 and negative 5 times negative 12. Do those add up to the b term? No, they don't. So those are not a possibility. Oh, this cat. So let's look at something else. Let's try 3 and 20. So I have positive 3 and positive 20, or I have negative 3 and negative 20. Once again, neither of those accomplishes what I need, which is negative 19. So can we think of any other factors that could possibly give us 60? Well, there's one more. How about positive 4 and positive 15, or negative 4 and negative 15? Again, we're looking for factors that add up to positive 19, and bingo, there we go. So let's go ahead and rewrite our expression. It's not an equation because it's not equal to something. It's just an expression as 5n squared. And then I'm going to split this positive 19 into positive 4n plus 15n plus 12. And let me put a little line here so you can see this. So those are separated. So what I'm going to do now is I'm going to look and see Is this an ideal sequence? Can I factor things out? When I factor things out by grouping, what I want to do is I want to establish a pattern. I want to establish something like this where I get two common terms. So sometimes in grouping you might have to rearrange some things. But let's try what we have. What can I factor out of 5n squared plus 4n? Well, the only thing I can really factor out is an n, and that leaves me with 5n plus 4. So does that help us? Well, let's check the second one. I have positive 15n plus 12. What can I factor out of 5 and 12? Well, actually, I can factor out a 3, a positive 3. So I'm going to factor out a positive 3, and that leaves me with 5n plus 4. If you look at that, is exactly what we're looking for. What can I now factor out of both of those terms? I can factor out a 5n plus 4. So I'm going to pull out 5n plus 4 from both terms, and that's going to leave me with n plus 3. And I'm finished. So that is how you use the AC method to factor trinomials. And again, when you factor a trinomial that has a lead term that's not 1, when it's a prime number, it's easier. When it's a composite number, it's going to be harder. So for example, if I wanted to cut corners, let's do number 2 by cutting corners. This is only for those of you that are a little bit more advanced. So I'm going to cut corners a little bit with number 2. I know that since it's 2n, my only possibilities can be 2n and n. There's no other way I can split this apart. I also know that my two factors have to either be 9 and 1 or 3 and 3. And one's got to be positive and one's got to be negative. So I'm looking for two factors that add up to positive 3. Again, I'm showing you, those of you that are more advanced, how you can figure this out. If you have a negative lead coefficient like you do for number 16 here, you do the same thing. You're going to follow the AC method. So negative 6 times negative 25. So that's a negative times a negative. So you're going to come out with a positive. And 6 times 25 is 150. So I've got to factor 150. Let me run through this real quick. Positive 150 means it's going to be negative, negative, or positive, positive. And I'm going to save you some time here because the video is longer to keep the video from getting too long. But I could go through lots of factors of 150. But bottom line is I have to have a negative times a negative, or I have to have a positive times a positive because it is a positive 150. Because a negative 6 times a negative 25 gives me positive 150. So again, just to save time, I look for a term that adds up to negative 25. Well, that's obviously going to be this. So I'm going to rewrite it. I'll have negative 6. Oops, I didn't mean to write it in that color. I have negative 6a squared. And then I'm going to split minus 15a minus 10a minus 25. So I've split it. So now let's factor our terms together. So I'm going to take a factor from here. What can I factor out of negative 6a squared minus 15a? Well, obviously I can factor out an a. But what else can I factor out? What do negative 6 and negative 15 have in common? What's a common factor? Well, negative 3a. So I could take negative 3a and I can factor that out, and I end up getting 2a, and that should be a positive 2. My program is drawing extra things for me. 2a plus 5. Then I'm going to look at my second group, negative 10a minus 25. What can I factor out? Well, I can factor out a negative 5, and that gives me positive 2a plus 5, which is what I'm shooting for. So for the final, I can factor 2a plus 5 out. and I get negative 3a minus 5 after I factor it out. So this is the same thing that we just did. I rushed through it a little bit, but as you can see, it doesn't matter if the lead term's a negative or not. Before you go through the AC method, always look at your terms and see if there is a common factor first. So let's look at 18. 18 looks like it's kind of a booger, right? 16, 60, and 100. Big numbers. But there is a common factor. Instead of you having to do 16 times negative 100 and get 1600 and have to factor that bad boy, you can do something that's preemptive. What do 16, 60, if I could actually draw here, and 100 all have in common? What is the greatest common factor between those guys? It's actually 4. I can actually pull a 4 out, and I'll end up with 4b squared plus 15b minus 25. Now, when that happens, I now will only focus on factoring this using the AC method. So that 4 is not going to disappear. It's just going to be kind of hanging out over here. And we're going to run the AC method with what's on the inside. So I've got positive 4 times negative 25, which gives me negative 100. Now what that means I'm looking for is a positive times a negative. Since I have a negative 100, I need to have a positive factor and a negative factor. Excuse me. Now to save time, I'm going to go ahead and give you the answer, and we're going to go straight to it. So you could have positive 5 and negative 20, negative 5 and positive 20, which turns out to be the correct answer. Again, I'm just kind of saving time for you. So when I take these two guys right here, those two are my factors of negative 100 that are going to give me the internal, the B term, the positive 15b. Now what do I do with that? Well, keep the 4. The 4 cannot run away. The 4's got to stay. So I've got 4b squared, but now I've got minus 5b plus 20b minus 25. And again, that's all on the inside. Dang cat is scratching again. So I'm going to do my factoring by grouping just like I did before. And again, the 4 needs to stay. So let's group the first part. I have 4b squared minus 5b. And what can I factor out? Well, I can factor out only a b. So if I factor out a b, I've got 4b minus 5. Now, I've got these two factors right here, these two terms, and I want to see what I can factor out. Well, I can factor out a positive 5 from both of them. So I'm going to factor out a positive 5, and that leaves me with 4b minus 5. And I've come to that point again where, and let's move this up a little bit, if it'll let me. It's not letting me. So I'm going to factor out, I got the 4, and now I'm going to do the factoring of the big terms. So I'm going to factor out the big common factor. I've got 4b minus 5 that I can factor out. And when I factor that out, I get b plus 5. So this actually turns out being your answer. 4 times 4b minus 5 times b plus 5. So that's how you actually factor when you remove the greatest common factor first. So always look at your 3 terms and see if you have something in common. If you don't have something in common, go straight to the AC method. But if you can find a common factor, factor that out first, then run the AC method with the expression that's left on the inside. And that is how you use the AC method.